So section 5.5 is all about function operations, which means that we are going to be adding, subtracting, multiplying. Who can guess the fourth one? Nice job. We are going to be adding, subtracting, multiplying, and dividing functions. So what that means is we are going to be taking more than one function and we are going to be doing things with them. We are going to be putting them together, okay? So we're going to be taking two functions and combining them into two different functions, or into one simple function. Now, sometimes it's going to be simple, sometimes it's not, but that's just something to kind of think about as we work our way through. We need to be able to take these functions and combine them, all right? Now, this is something that's going to be used way later on. It's not really, you're not really going to see the application of it for a little while. So really, if you want to know when are we going to be using this, we're going to be using this way later on down the road. There really isn't an example of when we're going to be using this or why we're going to be using this until way later. Okay, so if you're one of those people that wants to know why, it doesn't really exist. So just a quick notation, what things mean, okay? So if you are asked to add two functions together, the way that you are going to be asked to do that is like this. What this means is you are going to take whatever the function f is and add it to whatever the function g is. So in simple notation, it looks like this, where we take our two functions and add them together. Every one of the other functions will follow in the same kind of format. So when you subtract two functions, that means it's going to say f minus g of x, which is the two functions being subtracted. If you don't like function notation, where you don't like f of x and you don't like g of x, you got to get over it now because it's going to be pretty much non-stop until the end of the year. Multiplication, usually they won't put a dot or they won't put anything in there. They'll just put them next to each other like this. Oops. But if you do see it in the other way, or the simple way like this, they usually do put a dot in between. That is not a subtraction sign, it is a dot. So usually that's what's going to end up happening. But the big thing is they won't typically do dots in here because there is something called a composition of functions that we'll be getting to in a little while. And that composition of functions uses an open circle, which looks like a dot. So they try not to get that confused. Then the last one will be division. And what division looks like is f divided by g of x. So as we work through these, this is a very, very important concept for the future, like we said, but we need to be able to understand how to manipulate these functions, and we need to understand kind of like the domains and ranges and things about that, because that's going to be something that comes back to bite us later on. Okay? So the quick thing that I want to kind of mention is about domains. And domains are the possible x values. So domains are the possible x values of the function, okay? Now with these possible x values, you need to take into account each individual function, okay? So you need to consider each function. And the reason that you need to consider each function is because at the very, very beginning of the problem, you might throw away some answers or some possible x values. They're not allowed to come back later on. So let's say, for instance, we have something that looks like this, where we have a function that is f of x equals the square root of x, and g of x equals the third root of x. So let's say we have these two functions, okay? Now, the reason that I consider my domains right this second is because if I'm to combine these two things, it really wouldn't be a big deal. So let's say that I want to combine them and say f times g of x. So let's say I want to combine those, which means that I'm going to take f of x times g of x, So I'm going to do the square root of x times the third root of x, which I'm hoping that's not too bad. I'm hoping as you guys look at this, it's not too awful because you're just taking the thing and plugging it in, right? But now your job would be to simplify. And in order to simplify, you would then get x to the 1/2 power times x to the 1/3 power. What happens when you have two bases that are the same? You multiply, and I'm sorry, when you have two bases that are the same that are multiplying, what do you do with the exponents? Add them. So really now I'm saying I want to do 1/2 plus 1/3, which is the same thing as 3/6 plus 2/6, which is 5/6. So I'm going to get x to the 5/6 power. So now, that being said, I have to think about domains. If you only look at the end of the domain, or if you only look at the last part of a domain, sometimes you're going to end up missing answers. Sometimes you're going to end up missing things. Every once in a while, when you add or multiply or do things with functions, your final answer is going to look like there are no restrictions on it. But what I want you to think is, at the very beginning of this problem, if I ask you to consider function f and consider function g, are there any restrictions with numbers that I can plug in for function f inside the radical? Go ahead, Dan. I can't plug in any negative numbers with function f. So what I'm saying right now is with function f, I have eliminated exactly half of the numbers in the world, right? I have eliminated all of the negative numbers. I cannot plug those in. So what I want you to actually visualize is with this problem, with function f, I am literally taking all of the negative numbers and throwing them in the garbage can. I cannot use them anymore. It doesn't matter what happens. It doesn't matter what my other function is. It doesn't matter anything at all. But with one of my functions, all of the negative numbers are in the trash can. They do not exist. They don't work. Which means that no matter what happens throughout the rest of the problem, negative numbers do not exist in this problem anymore. Because function f has gotten rid of them. You can only use numbers that work for both functions at the very beginning, in the middle, and at the end. If at any point any of those numbers do not work, they get thrown in the garbage and they cannot be used again. So I don't care what your final answer looks like. I don't care what your stuff in the middle looks like. I don't care what your stuff at the beginning looks like. If you take numbers and throw them away at any point during the problem, they no longer exist. Okay? Not at all. Okay? That's what you have to kind of think about. No matter what, at any point during this process, if you say my domain has been restricted, or these numbers don't work, or I can't have any numbers less than something, visualize yourself picking them up and throwing them in the trash can. They no longer exist. Okay? So the domain of this one is restricted to the domain in the range of the ones up at the top. Okay? So there's really three spots that you have to look for domain and range. Number one, you have to look at the very beginning of the problem. Number two, you have to look at the very end of the problem. And number three, you have to see if there are any x's in the denominators. Okay, so those are the three things I'm going to write on the board so that you can see them. All right, so I want you to be able to understand these and think about them because there are three very important spots that you need to check. All right, first spot that you need to check is you need to check the first functions. So at like the beginning, you need to check the end of the function. So I guess this would be the end. And then you need to check for x in the denominator. Because if x shows up in the denominator, that means that x can't equal 0. All right? And most of the time, I'm not going to say all of the time, but most of the time that you're dealing with these things right here, you are looking to see if there are even roots anywhere in the problem. That's really what you're looking for. Because in most cases for us, what shows up as an issue is when you have an even root. Because if you have an even root, that means exactly what Tanner said a little while ago, where you can't have a negative inside the radical, right? So if you have an even root, you can't do negatives inside radicals, and most of the time that's what's going to happen with these sort of restrictions. Questions? Issues or anything so far? All right, so let's run through some examples so that we can kind of see what it looks like, so that hopefully you guys can kind of understand how we work through these two things. All right, so let's say we have something like this, where we have f of x equals 3x to the third power minus 2x squared plus 5. And then we're told that g of x is equal to x to the third, that's 3x squared, 4x minus 2. So that's how these problems usually start out. And then what's going to end up happening is it's going to give us some sort of operation. It's going to give us some sort of operation. The operation is either going to be addition, subtraction, multiplication, or division. Okay? Most of the time, they're not going to make you do multiplication or division with these types of fractions, or these types of functions. And the reason they're not going to ask you to do that is because that would be an unbelievable amount of work for not a lot of payoff. All right? So most of the time, they're not going to ask you to multiply or divide these, because that's a ton of work. Okay? These types of problems are usually going to be addition or subtraction problems. So let's say that we want to subtract these two. So let's say that we want to find f minus g, and it wants you to find f minus g of 2. Okay? So just getting you familiar with the notation, because that's what it's going to be, is a lot of notation. On the left, you see where it says f minus g of x. What it wants you to do is it wants you to take the function f and subtract the function g. On the right, it wants you to take the function f minus the function g, get your simplified answer, and then plug in 2 for x. That's what it wants you to do. Okay? These problems are as simple as combining like terms. That's what this basically is. Okay? So right now, what it wants us to do is it wants us to do f of x minus g of x. And the only thing that we can do to simplify this anymore is to start combining like terms. So our f of x is 3x to the third minus 2x squared plus 5 minus my g of x is x to the third minus 3x squared plus 4x minus 2. What I have written on the board is what I would expect most people to write down most of the time, the very first time that they see this, but this is not the way that I would write it down. Okay, I've written it down like this so that you can see what the common mistake is that people make when writing these problems. Why is this an issue? Go ahead, Mike.
Well, maybe this is, would you need to put the 0 in as well?
Not necessarily. I mean, you could if you wanted to. So what Michael is saying is there's no like x term in the black one. So if there's no x term in there, I might want to throw in a 0 in there. That might be a good idea. Go ahead, Chase. I should put parentheses around it. All right. So when I put parentheses around here, I now know that that negative has to be distributed. All right. If I don't put parentheses around there, that negative is not going to get distributed into every single one of those things. But I need to subtract every single one of those from the original terms. And you're not going to subtract every single one of those unless you put parentheses around it. Because notice when I didn't have parentheses, it looked like I was only subtracting one thing. All right, that's a big thing that people miss. And it's something that is as simple as putting parentheses around it to make sure you're not going to make that mistake. Okay. Now, the one thing Michael brought up about putting in a 0 is a really, really good idea, and I'm going to explain that to you again in a second. All right, I'm going to show you why that's important as well. All right, so we're going to do it without first to make sure to see if we don't make any mistakes. But now we're going to combine our like terms. So I have a 3x to the third minus x to the third. 3x to the third minus x to the third is going to give me 2x to the third. I have an x squared term, so I have negative 2x squared minus negative 3x squared, right? Negative 2x squared minus negative 3x squared is going to give me a positive x squared. Now I have something in a 4x, so I'm going to do positive 4x. And then 5 minus negative 2, which is 7. I'm hoping that you find issue with my answer. I'm hoping. Because if you don't find issue with my answer, you are the type of person that needs to put the 0 in there. Ryan, what happened?
Oh, I was gonna say, it should be a minus 4x.
Should be a minus 4x, right? Some of you are very, very good at seeing this immediately, and you won't make this mistake. Some of you are not. But remember how when we did long division, I always said that I take my pencil and I actually touch exactly what I'm saying every single time that I say it? I'm doing the same thing here, right? 3x to the third minus x to the third. Negative 2x squared minus negative 3x squared. There's nothing here. There's no x term. So if you are the type of person that thinks you're going to make this mistake, put a plus 0x in there. It takes literally 1 second, and then you won't make that mistake because now you have a 0x minus 4x. 0 minus 4 is negative 4, which means this has to be a negative symbol. All right? So that's what I would suggest to you if you're the type of person that makes those mistakes often. Okay? So if you're the type of person that makes sign changes or sign errors often, put that 0 in there and make sure you're not missing anything. All right? Now the very last thing would be to plug in 2. So now when we plug in 2, this function right here is equal to, the way that your final answer should look is f minus g of x is equal to that. That's what that should look like. F minus g of x is equal to whatever that thing is in red. And then now what it wants you to do is solve for when x equals 2. So now it's f minus g of 2 is equal to, we just plug 2 in for all of those x's. So I get 2 times 2 to the third power plus 2 squared minus 4 times 2 plus 7. All right, should be pretty straightforward. Yeah.
And so if it was something like that, it's gonna be a row like that every time, where the x is just replaced with a number.
Yes. Yep.
Because it just looks a lot like you're multiplying the
Right.
answer,
And what Sean just said is very true. It looks like I'm taking this function and multiplying it by 2. That is absolutely what it looks like. But the notation is asking you to find what happens when you plug 2 into this function. You got to remember, function notation is a lot different than normal notation, right? So when we sort all of this out, we're going to get 2 times 2 to the third, which is 8. So 2 times 8 plus 4 minus 8 plus 7. So 16 plus 4 minus 8 plus 7 is 19. So I end up getting 19 for f minus g of 2. We all good? All right, if you have questions about that, let me know. Addition and subtraction are the same. I'm going to run through one multiplication problem, which is I'm sure where I'm going to pick up tomorrow. So I just want to make sure that you guys understand and see what I'm talking about. Okay. So let's say that I've got 2 functions, and those functions, again, I think they usually stay with f and g. They could change it if they wanted to and call it like h of x and k of x or something like that. But usually they stick with f and g. So let's say that we've got 11x to the third and 7x to the 7th. So let's say that we have something like this. What I want you to try to find is I want you to find fg of x. Find f divided by g of x. And then find both when x equals -8. So that x equals -8 should just be as simple as plugging something in. But find f g of x, find f divided by g of x, and then find both of those when x equals -8.